Today we're starting the last lesson in this unit. If you notice the note at the top of your subplan page for today, we're shooting for a test this coming Friday, so just kind of keep that in the back of your mind. Last lesson is on solving exponential and log equations. We've done a little bit interspersed throughout the unit, but now we're going to hit it pretty heavy. All of the first ones are exponential. Some of them you have seen before, some of them we're certainly going to up the difficulty. So starting really with 1 and 2, our goal is to get it so that the exponential piece is isolated. In other words, I want to get 2 to the x isolated. So I'm going to add that 5, and I'm going to go ahead and divide by 3. And I'm just going to leave it in that format because 293 divided by 3 does not come out to be a nice even number. We've got an exponential form. Certainly 2 to what power gives you 293 over 3? We don't know, so we can flip it to log equation. Keeping in mind a log is an exponent. That quickly lets me know that that x is going to go over here. The base that goes down here is the same base that's being raised to a power. So we have log base 2 of 293 over 3. Now that it's in that form, we can use that change of base formula. We've got log of 293 over 3 divided by log of 2. Now we discussed, some of you have the nicer calculators, you have that automatic change of base. If you don't, that's okay, we can still type it in on the older calculators as well. So just to make sure you're with me there, I have log of 293 divided by 3. There we go. And I'm going to divide that by the log of 2. And we get the following answer. I'm coming up with 6.61. And if we wanted, we could check that. We can go back and type that in. So 3 times 2 to the 6.61 minus 50. It should give me something close to 243, and it does. Moving on to number 2, same idea. I need to get that 1/2 isolated, and this is difficult to see, but there's a t in there. Let's actually change it to an x over 3. We're going to divide by 20. We get 5 over 20. We could reduce that to 1/4, which means we actually can change that to 0.25. A couple different ways we could solve this. We don't have to flip it to log form. Let's talk about that. We've got 1/2 to the x over 3 equals 1/4. I'm going to rewrite this so that it has the same base. In other words, if you think about it, I could rewrite 1/4 as 1/2 to the second. We've got 1/2 x over 3 equals 1/2 to the second. Now we can set those exponents equal, and we end up with x is equal to 6. If you don't see that, we can go and do the same thing that we did here. We could take this, we could flip this to log form. Again, keeping in mind a log is an exponent. I'm going to quickly put that x over 3 off to the right. My base is 1/2 of 1/4. Again, I can go use change of base on my calculator, log of 0.25 divided by log of 0.5. We end up with 2, and again, notice you get the same answer of 6. Moving on to number 3, same thing. The only difference is we've got a base of e instead of a nice integer base. I'm going to subtract that 3, and I'm going to divide by 2. That ends up giving me 3 over 2. Again, no idea on this one. Flip it to that log form. Technically, this would be log base e of 3/2 equals negative x. Remember, log base e has its own special button on your calculator. That is the natural log. In this case, I don't have to use that change of base because the natural log has its own button. I've got natural log of 3/2. I end up with 0.4 equals negative x. Divide by that negative, and I get negative 4.05. And again, you can check that on your calculator, just substituting that in, verifying we get something close to 6, and I did not, so I'm thinking I did something wrong. Pause and take a look. I went back and double checked. When I plug in this negative, the negative negative turns to a positive. When you plug it in, it does check out. Okay, moving on to number 4. This is probably one of the most difficult ones that we're going to see. The easy method would be to go ahead and graph it. So let's talk through that. I'm going to pause my video, plug those in and get it set up, and then we'll talk about how we would do this algebraically as well. Alright, easy method, as I said, graphically. I graph the left side, I graph the right side. We're looking for that point of intersection, going into second calc. I'm going to go intersect, and we end up with a solution of 2.08. Now, we are in pre-calc. We got to push ourselves a little beyond. You're going to do the very best you can with this. Hopefully you can pick up on a little pieces, and we'll continue to work on it as well. First thing I'm going to do is multiply by 3. Now, right now, I'm dealing with this negative exponent, which I don't like. That makes it a lot more difficult to do. So I'm going to multiply everything through by 2 to the x power. Watch what happens when I do that. When I multiply these, I have 2, I add the exponents, I get 2x. When I multiply these, again, base stays the same, but notice when you add x and negative x, you get 0. That's going to make that a lot more easy to deal with. So this simplifies to 1, and I'm going to bring this term over here. I've got 2 to the 2x minus 12 times 2 to the x, and this becomes a 1. Now, believe it or not, in here I actually have a hidden quadratic. I'm going to let y be equal to 2 to the x power. That means this I can rewrite as y squared, this I can rewrite as 12y, and then I've got a 1 over here. Again, do the best you can, we'll work on it some more. This is a quadratic. Unfortunately, it is not factorable. I do have the solutions already worked out for us, though. When I went and used the quadratic formula here, I ended up with y is equal to, one of them was an error, so that would be undefined. We don't have to worry about that. And the other one is y is equal to 12.205. Okay, I just found an error when I typed in my calculator. I forgot to divide by 3 on the left, so my solution is actually 3.59. Okay, I know this is my end result. We're going to keep plugging away with the algebra. Remember back over here, I let y be represented by 2x, so I'm going to replace y back with my 2x. Now I have an exponential equation. We're going to flip this to log form. Again, using change of base or your nicer calculator, again, you end up with a solution of 3.59. Again, probably not your method of choice to solve, but gotta push because at some point, again, if we take away that calculator, we need to know how to solve it algebraically as well. Second part, we're looking at what happens if we have log equations. So kind of the same format as what we did above. We got it simplified and then we flipped it to the opposing form. I'm going to do the same thing here. In other words, it's in log form. I'm eventually going to isolate that log and then flip it to exponential form. I'm going to subtract the 5, which would be 16, and divide by that 4, and can't solve this in the form that it is, so I'm going to flip it to exponential form. We've got 3 to the 4th equals 3x minus 1. Now I can solve this. 3 to the 4th is 81. I'm going to add that 1 and divide by 3, and that's as far as I can go. Again, if I go back and I plug it in, 3 times 82 over 3 would be 82, minus the 1 would be 81. 3 to what power gives you 81 would be 4. 4 times 4 is 16, plus 5 is 21. Certainly you can plug it in your calculator, but you also could do this one by hand. Next one. Again, we want to get this down to a single log. Here comes some of those properties. The first thing I'm noticing is that 2 is going to become a power. I've got natural log then of x squared. Remember, when do we subtract the exponents? When we are dividing. It's in log form. We're going to flip it to exponential form. We've got an e. This becomes e to the first equals x squared over 3. We're going to multiply by e. Eventually take the square root. If they ask us to leave it in exact form, we're going to leave it like that. If they want us to take it to a decimal, okay, when I plug that in my calculator, I got x equals 2.856. Moving on to the back side. C and D are pretty similar, so I think we'll take a look at C and E. If we look at C again using those properties, actually that one's pretty similar to the one that we just did. We're going to take that power, becomes, and here's the only thing, notice it's going to be a power on both of those. That becomes log base 2 of x over 4x squared. If we take a look, we can simplify. That would become 1 over 4 times x. We've got the log isolated. Again, we're going to flip it to exponential form. 2 to the 5th equals 1 over 4x. 32 equals 1 over 4x. We're going to cross multiply. 128x is equal to 1. Finally, we divide and we end up with 1 over 128. Moving on to E. This one, if you notice, you've got natural log, or you've got a log on every single term that you have. The only thing I'm noticing is I'm going to have to deal with that power property right here. So this actually becomes 2 to the 3rd. If all of your logs are the same, that really means we can focus on what's left, meaning we've got x minus 3, but keep in mind, we use that product property, would be times x plus 4 equals 2 to the 3rd. We're going to go ahead and FOIL this out. We've got x squared plus 1x minus 12 equals 8. We're going to bring over that 8. And now we can factor. We've got x plus 5, x minus 4, setting those equal to 0. We would end up with x is negative 5 or x is 4. However, if you plug in negative 5, we talked way early on, we cannot have a base to a power that ends up with a negative exponent. So that means we just end up with x is 4. I'm jumping to number 7, just for sake of time. We've got about 45 seconds. So I'm plugging into that continuous, the PERT formula. I'm going to take the 331.07 divided by my initial amount. I end up with 1.65535 equals e to the 0.084t. Now I'm going to flip it to log form. Alright, I went ahead and worked ahead just a little bit. When I flip it to log form, this would be log base e of the 1.65. Remember, that actually means natural log. I plug that in my calculator, and then finally I divide by the